Dear students, welcome to the second session of our chapter 11 P block elements. In this session, we will discuss some of the chemical properties of the 13th group, that is the boron family. Let's see the oxidation state. Due to the small size of boron, the first three ionization enthalpies sum will be very high, and it prevents to form what plus 3 ions or plus 3 cations. But as we move from boron to aluminium, we can understand due to the sum of the first three ionization enthalpy decreases, it is therefore able to form Al3 plus ions. And aluminium is highly electropositive metal. However, down the group, due to poor shielding effect of the intervening D and F orbitals, because as we go down, the number of shells increases, and there we have the orbitals D and F. Okay, and because of these D and F orbitals of poor shielding effect, what happens? The increased nuclear charge, effective nuclear charge, holds the NS electrons very tightly, the outermost electron very tightly. That is responsible for the inert pair effect, and it restricts the participation of bonding. And as a result, what happens? Only the p orbital is involved in the bonding. They will not allow the d and f orbitals to for participate in the bonding. So in fact, what gallium, indium, thallium, they both have what the plus 1 and plus 3 oxidation states. The more stable one is what plus 1 oxidation state for the higher element. And the order is like aluminium less than gallium less than indium less than thallium. In the trivalent state, that is when the plus 3 oxidation state is there for the 13th group, the central atom of a molecule, if we consider the boron trichloride, the boron is the central atom and it has how many electrons around the central atom? 6 only. That means what? It is not accepting or it is not obeying the octet. So we can name it as what? Electron deficient molecule. And what they have the tendency to accept a pair of electrons to achieve a stable electronic configuration. And they will behave as Lewis acids. That means a molecule which is accepting a pair of electrons to become the stable configuration is said to be Lewis acids. Now we are giving here the example of boron trichloride, which accepts a lone pair of electron from ammonia to form BCl3NH3 molecule. Now you can see here the Lewis structure of NH3, where the 3 electrons are used for the hydrogen bond and the 2 lone electron is there for ammonia. So it will act as Lewis base. Who is accepting the electrons that will act as what? Lewis acid. So boron trichloride, when it has only 3 valence electron, it is used up with the chlorine. No electron is there. That means 6 electrons are around the central atom. So it will accept a pair of electron from the ammonia. So it will act as Lewis acid. Now here a dative bond is formed. We know the coordinate bond is named as dative bond. That means one side sharing is only there. You can see here the lone electron. The 2 electrons are given to the boron. It is not giving to nitrogen. That means only one side sharing is there. That means no mutual sharing is here. So that is the difference between the covalent bond and the dative bond. So this type of bond formation is there in the 13th group elements. Aluminium trichloride, it attains the stability by forming a dimer. That means 2 molecules of aluminum chloride will be there, which is a stable configuration. Otherwise, we know that it is an electron deficient molecule. So this is the structure for aluminium trichloride. Now let's see the trends or chemical trends in the reactivity. The first one with the air bubbles. Boron is unreactive in the crystalline form. Aluminium forms a thin oxide layer on the surface which protects the metal from further attack. So when we buy or purchase an aluminium vessel, we know that after some time it becomes a fade color. The corrosion is happening there. A thin oxide layer is formed on the surface of the metal. Amorphous boron and aluminium metal on heating in air forms boron oxide and aluminium oxide. With nitrogen at high temperature, they form their nitrides. So this is how the reaction is there with the air. The nature of these oxides down the group varies. Boron trioxide is acidic in nature and it reacts with basic oxides or metallic oxides, forming the metal borates. Whereas the aluminium and gallium oxides are amphoteric, and those of indium and thallium are basic in their properties. So the nature how it varies down the group, first acidic, then amphoteric, and last one basic. This is the nature of the reactivity or the reactivity of the oxides down the group in 13th group. Now let's see the reactivity towards the acids and alkalis of 13th group. Boron does not react with the acids and alkalis even at moderate temperature, but aluminium dissolves in the mineral acids and aqueous alkali, and it shows the amphoteric character because both characteristic it is having acidic character as well as the basic character. The reaction towards the halogens. The elements react with halogens to form the trihalides. Except the thallium iodide, we can have all the halides for this group. As we go for the uses of boron and aluminium compounds, we can see here as the boron is very hard and it has high melting point, low density, low conductivity, many applications are there. Boron fibers are used in making the bulletproof vest and light composite material for the aircraft. The main industrial application of borax and boric acid is in the manufacture of heat resistant glasses, that is pyrex, glass wool, and fiber glass. So there are many uses of boron which is due to the hard nature. If we take for the aluminium, it's a bright silvery white metal and it has high tensile strength as well as high electrical and thermal conductivity. So it forms alloys with copper, manganese, magnesium, silicon, and zinc. Aluminium and its alloys can be given shapes of pipe, tubes, rods, wires, plates. There are many uses of this aluminium, and even in the transportation industry, we are using the aluminium alloys. Vessels are there, which or the utensils are there for the household purpose. So there are many uses of aluminium as well as boron. Thank you. We'll continue in the next session.